Hello everyone. Good morning, good afternoon, good evening. Today we are going to learn VPC Consistency Check and its failover scenarios. So let me enable the pen and then we can go ahead. So before that, we will learn what is the Cisco Fabric Services CFS protocol. So Cisco Fabric Services is enabled by default as soon as a VPC feature is turned on. CFS messages are encapsulated in the Ethernet frame and is tagged for POS4 for reliable communication. So as soon as we enable the VPC feature, the CFS protocol start working and it starts sending a packet. So, it has a following functions. What it does, first thing, it it do the configuration validation and comparison. Configuration validation and comparison. Okay. Second, synchronization of MAC addresses for VPC member port. Synchronization of MAC address of VPC member port. Third, VPC member port status advertisement. Okay. Fourth one, STP management. Fifth one, synchronization of HSRP and IGMP snooping. HSRP and IGMP snooping. Okay. Now, the CFS plays a major role, for the VPC consistency check. So there are two type of consistency check, present. So as soon as VPC feature is, enabled, CFS start working, and after the configuration is done, then via CFS protocol, it checks and validates the configuration at both peer devices. And based on the configuration validation and comparison, CFS divides the configuration and its error into two types. So there are two types of error checks. One is, type 1. If you are having a type 1 inconsistency, then the VPC system will put the peer device or interface into the suspended state to prevent the invalid packet forwarding behavior. With a VPC graceful consistency check, suspension occur only on a secondary peer device. So if you have a peer two devices, right? Let's suppose if I have two devices, right, and I have configured some configuration, and those configuration mismatch falls under a type 1. So what will happen? The VPC system on the secondary device, it will shut down this port so that all your traffic will go via primary devices. But if your configuration error is of type 2, the peer device or interface will still forward the traffic. However, they are subject to undesired packet forwarding behavior, and a moderate action or a no action or any preventive actions is taken when the type 2 inconsistency check is found. So let's see, in the type 1 consistency check. So when the type 1 inconsistency is detected, then following action is taken. So let's understand, in type 1, there are two type of configuration. One is global configuration, which is done on a global level, and another one is a interface configuration. If any of these configuration this falls under a type 1 inconsistency error, right? So for a global configuration type inconsistency check, all the VPC member port are set to down state. And for the interface configuration also, the misconfigured VPC is set to down state. So in a nutshell, what we can say, if any configuration that happens either in a global configuration mode or at an interface level, and that configuration lies in a type 1 as a type 1 inconsistency check, in both cases your VPC member port on a secondary device will be down. Okay, now if you want to see I mean the consistency check or global parameters, then you have to write a command, show VPC consistency parameter global. So this is command, you can write it and test it. Okay, now what is I mean the question arises, what type of configuration falls under global and what type of configuration falls under interface level at a type 1. So for a global parameter configuration, HTTP modes, right? HTTP region configuration for MST, for MST, HTTP global settings, like bridge assurance, like port type setting, right? Like loop guard setting, like BPDU filter setting, like MST simulate PVST enabled or disabled, right? So these are some global commands that must have to match between your VPC peer devices. If any of these commands mismatch, it will come under type 1. So what is your interface level command? Interface label command. So port channel mode, either it can be on or LSCP or active, passive. Port channel speed, okay. Duplex mode, okay. Switch port mode, port per port channel, mode per port channel. HTTP interface setting, like loop guard, root guard at interface level. Okay. MTU per port channel, okay. So these are the command that lies under a interface level, and if any of these command mismatch between a peer switches, the type 1 inconsistency error will be detected, and on a secondary switch the member port will go down. Now let's see what is a type 2 consistency check. So when the type 2 inconsistency check is detected, moderate action or no action is taken. So for a global configuration type 2 inconsistency check, all the VPC member port will remain up and VPC system triggers a proactive actions. Now for a VPC interface configuration type 2 inconsistency check, the misconfigured VPC remains in up state, but they depending upon the discrepancy type, VPC system will trigger a proactive actions. So for an interface level, the traffic will go, the VPC system will be up, but it will trigger a proactive action. So let's suppose take an example. You have, on a one VPC member port, you have, allowed a VLAN, but on the second port, you have not allowed. So in that case, VPC system will disable the, it will disable that particular VLAN from VPC interface that doesn't match on both sides. So in that case, rest of the VLAN traffic will be allowed from that interface, but for that particular VLAN, the traffic will be not allowed. So my port remains up, my all other traffic will still be going, but a preventive action or a moderate action has been taken in terms of VPC type 2 consistency check. Now, in type 2 also, there are some, configuration that falls under type 2. So what are those? So MAC aging timer. Okay. Static MAC entries. Right. SVIs. Right. ACL. Spanning tree, interface setting. Interface setting, under which, we can write it BPDU filter. Link type. I mean, auto, you can say point to point. Okay. Port priority. Port priority. HTTP interface setting. Interface setting, right? VLAN database. Port security. Okay. And DSCP snooping. HSRP or layer 3 protocol. So these all, comes under a type 2 consistency check. So in type 2 also, we have a global configuration and we have a interface level. Okay. And in the global configuration, type 2 inconsistency check, all the VPC member port remain in up state and VPC system triggers a proactive actions, right? Whereas in the interface, also, my VPC system, remains up and it takes a proactive, protective actions, like, if a particular VLAN is allowed on a one member port and if it's not allowed on another member port, then that particular will be down, VLAN will be down, and rest all other traffic from that port, trunk port, will be allowed. Now we will see, what is the VPC failover scenario. So if we learn about the VPC, what we have seen that when we see the component of the VPC, so this is my VPC system, this is my primary, this is my secondary, this is my access switch, this is my peer link, and this is my keep alive. Right now, let's suppose what will happen, if my peer keep alive fails. So during a peer keep alive link failure, there is no impact on a traffic flow. but it is recommended to restore the keep alive link as soon as possible to avoid a dual active or a split brain scenario. So if this keep alive goes down, there is no impact on a traffic flow. Now, what happens if my peer link failure, right? So if my peer link failure, right? So the actions happens on a stepwise. So on first step, peer link goes down. Right? As soon as it goes down, peer keep alive hold timeout timer activates, and up to 3 seconds it will ignore all keep alive packet. Third, after 3 seconds, keep alive timeout timer is activated. Okay, and the secondary switch will perform the following actions, because after 3 seconds keep alive link is still sending a packet, and if any of the keep alive packet is received on a secondary switch after keep alive timeout timer is expired, this secondary switch or VPC system will take a following actions. What is those actions? On a secondary switch, it suspends VPC member port. Okay, and on secondary switch, all SVI associated with VPC VLAN goes down. So my member port also goes down, and my all SVI also goes down. So I have only one path to send my traffic, right? Now, what will happen if the peer keep alive link fails? After that, my peer link fails. So in that case, when I have a VPC peer link fails first, and then a peer, when a VPC keep alive link fails first, and then a peer link fails, the VPC primary switch continues to be primary, but the secondary switch will also become a operational primary switch, because my peer link is also failed and my keep alive is also failed. So there is no way so that I can inform my both switch that I am alive. They both switch will feel that I am a primary operational primary. So the primary switch will be primary and the secondary switch will become operational primary, and the VPC operational switch will keep its member port up. And this scenario is also called as a dual active scenario, and this situation is called as a split brain scenario. So in that case, what happened for the existing traffic, right? So in this scenario, there is no loss of a traffic for existing flows, but for a new flows, can be affected as peer link is not available, and the two VPC switches cannot synchronize their unicast MAC address, and therefore they cannot maintain a complete unicast and multicast forwarding table, and there may be some duplicate packet forwarding. So for existing traffic there won't be any problem, but for a new type of traffic there will be always some problem. because the both VPC switch are not able to synchronize their MAC address, and they are not able to maintain their unicast and multicast forwarding table. Now, my fourth one is what happens when my primary switch failures. So in a VPC topology, if a failure occur on a primary switch, then a secondary switch will become an operational primary switch. And if the primary switch come back it again, it will take a role of operational secondary. Okay. So thank you for watching VPC consistency check and failover scenarios. Thank you very much. Take care. Bye bye.